Earth's story begins over 4 billion years ago. The planet was a hostile world of molten rock. It was a place of violent volcanic eruptions, and it was scarred by constant meteor impacts. Yet within this incredible chaos, something began. The first chemical reactions in the primordial oceans sparked the origin of life. The earliest organisms were simple. They were microscopic and single-celled. They thrived in shallow seas and near hydrothermal vents. These microbes left behind some of the oldest fossils known to us today. They are called stromatolites. These are layered structures like stony pillows. They were built by vast colonies of photosynthetic bacteria. Through billions of years, these tiny architects transformed the entire planet. They slowly released oxygen into the atmosphere. This oxygen was a gas that would eventually allow larger, more complex creatures to evolve. For most of the pre-Cambrian era, life remained invisible to the naked eye. It was a world of quiet, microscopic adaptation. Life spread slowly across the vast, silent oceans. Then around 600 million years ago, an extraordinary shift occurred. This was the Ediacaran period. Strange, soft-bodied creatures emerged. They were unlike anything alive on Earth today. They floated, crawled, or attached themselves to the seafloor. They formed the first true animal communities. Fossils from this time have revealed jellyfish-like forms. They show frond-shaped organisms that swayed like alien plants, and they show flattened, quilted shapes that puzzle scientists even now. While many of these mysterious species vanished, they represented an important step. It was a step toward complex ecosystems. This strange period paved the way for one of the most dramatic evolutionary events in history. This was the Cambrian explosion. It happened around 541 million years ago. In just a few tens of millions of years, the oceans filled with an astonishing variety of creatures. Each one was experimenting with new designs and new survival strategies. Predators with sharp claws and advanced eyes appeared for the first time. They hunted alongside armored prey that had developed spines and hard shells. This period set the foundation for nearly every major animal group we know today. From the silent beginnings of microbial mats, a journey began. It moved to the strange alien forms of the Ediacaran, and finally it arrived at the bustling diversity of the Cambrian seas. Life on Earth had moved from simple beginnings to the edge of a terrifying new age. It was the age of predators. Around 541 million years ago, the world entered a turning point. It was a moment that forever altered the trajectory of life on Earth. This was the Cambrian explosion. It was a relatively brief window of time when evolution accelerated with unprecedented speed. For billions of years, life had remained largely simple. It was composed of microbes, algae, and a handful of strange, soft-bodied organisms in the Ediacaran seas. Then almost suddenly, in geological terms, the oceans came alive. They filled with an extraordinary and shocking diversity. Creatures with hard skeletons, jointed limbs, complex eyes, and sharp teeth appeared. They began carving out ecological niches in ways never before seen. In the span of less than 30 million years, the blueprint for nearly every animal group alive today was established. The seas became brutal arenas of survival. They were filled with monsters, both terrifying and utterly alien. The oceans of the Cambrian were vastly different from the world we know now. Shallow continental shelves stretched across much of the planet. They were bathed in sunlight and were rich in nutrients. These conditions created fertile grounds for life to experiment with new forms. Trilobites, perhaps the most iconic of all Cambrian creatures, crawled along the seafloor in massive numbers. Their segmented, armored bodies provided excellent protection from predators. Their compound eyes were among the earliest advanced visual systems on the planet. These eyes gave them a crucial edge in detecting danger. Trilobites were not just small curiosities. They came in a wide range of sizes. Some were only a few centimeters long, others were giants, more than half a meter in length. They filled multiple roles as scavengers, grazers, and prey. They formed a cornerstone of the Cambrian ecosystems, yet the trilobites were far from the most fearsome creatures of their time. Among the apex predators was a creature named Anomalocaris. Its very name means abnormal shrimp. It reached lengths of up to 1 meter, a true giant for its time. This beast was equipped with 2 spiny grasping appendages at the front of its body. With them, it snatched up trilobites and other prey. It crushed them with a circular, tooth-lined mouth. Its large, stalked eyes contained lenses numbering in the thousands. This gave Anomalocaris exceptional vision. It was one of the most advanced hunters of its age. Swimming gracefully with undulating flaps along its body, Anomalocaris embodied the dawn of active predation. This was a shift that transformed life in the seas into a brutal, constant struggle for survival. The rise of predators like Anomalocaris sparked an evolutionary arms race. Organisms that had once floated passively or filtered nutrients from the water now faced extinction. They had to adapt or die. In response, many developed hard shells, sharp spines, and hardened exoskeletons. These were innovations that offered protection, but they also fueled the need for even stronger predators. This feedback loop of adaptation and counter-adaptation is one reason the Cambrian explosion was so dramatic. Evolution was accelerating under the intense pressure of survival. Creatures like Wywaxia, which was covered in long defensive spines, looked otherworldly. So did Hallucigenia, with its bizarre array of spiky protrusions. But their unusual designs were functional defenses in a very dangerous world. Another equally strange organism was Hallucigenia. It was a worm-like creature no longer than a human finger. Its fossil reconstructions baffled researchers for decades. It appeared to walk on thin, spindly legs. At the same time, it sported rows of sharp spikes along its back. For a long time, paleontologists even displayed it upside down. They mistook its defensive backspines for legs. Despite its odd appearance, Hallucigenia was an important part of the Cambrian ecosystem. It represented the early stages of evolutionary experimentation with body symmetry and defense. Its lineage, though bizarre, would eventually contribute to the arthropods. This is the group that includes insects, spiders, and crustaceans today. The Cambrian seas also hosted a variety of armored worms and early mollusks. Wywaxia, with its leaf-like scales and sharp dorsal spines, may have scraped algae from surfaces. It survived more by defense than by offense. Picaia, a small eel-like swimmer, is particularly important. This is because it is one of the earliest known chordates. These are animals with a notochord, the precursor to the vertebral column. Though only a few centimeters long, Picaia represents the humble beginnings of a very important lineage. It was the lineage that would eventually lead to fish, reptiles, mammals, and humans. In the shadow of monstrous predators and armored invertebrates, the first stirrings of our own vertebrate ancestry quietly unfolded. The Cambrian explosion remains one of the most puzzling mysteries in science. Why did life diversify so suddenly after billions of years of relative simplicity? Several factors likely combined to cause this event. Oxygen levels in the oceans had risen significantly. This enabled higher metabolic activity. It provided the energy required for larger, more complex bodies. The breakup of supercontinents created new, shallow marine environments. These environments were rich in nutrients. Genetic innovations, such as the development of Hox genes, also played a role. Hox genes are the master regulators of body plans. They allowed organisms to experiment with new forms more rapidly. And of course, the rise of predation created relentless pressure for adaptation. Together, these forces unleashed a cascade of evolutionary possibilities. This resulted in the incredible burst of life we now call the Cambrian explosion. As the Cambrian explosion waned and the Ordovician period began around 485 million years ago, life on Earth did not slow its pace of innovation. Instead, the seas became even more crowded. They were filled with new predators and new prey that pushed evolution forward in extraordinary ways. The oceans spread widely across the planet. They were shallow and warm, creating vast habitats teeming with opportunities. In these waters, invertebrates continued to dominate, but their forms grew stranger, larger, and more lethal. Among them rose some of the most terrifying hunters Earth had ever seen. There were giant squid-like cephalopods with towering shells. There were sea scorpions as long as a human, and there were the first daring creatures that crawled from the water onto the uncharted frontier of land. The Ordovician seas were ruled by cephalopods. These were the distant ancestors of today's squids and octopuses. Unlike their modern relatives, many of these animals carried long conical shells. These shells gave them both protection and buoyancy. The largest of them, Orthoceras, could grow several meters in length. This made it one of the most formidable predators of its age. With tentacles stretching out from its shell and sharp beak-like jaws, Orthoceras patrolled the oceans. It was like a submarine of flesh and bone. Smaller animals stood little chance once they were ensnared by its grasping arms. Their sheer size alone meant that few creatures could challenge them. For millions of years, they reigned as the apex predators of the Ordovician seas. While cephalopods hunted in the open waters, another group of monsters lurked in the shallows. These were the Eurypterids, better known as sea scorpions. These were arthropods, relatives of modern scorpions, spiders, and crabs, but their scale dwarfed anything of their lineage alive today. Some species grew over 2.5 meters long. This made them the largest arthropods to ever exist. With their powerful clawed appendages, paddle-like limbs, and heavily armored bodies, the Eurypterids prowled coastal environments with unmatched dominance. Some swam with surprising agility. Others may have stalked their prey along the seafloor. Their powerful pincers could crush fish and invertebrates alike. Their sheer presence turned the shallows into places of constant dread. It is difficult to imagine an ocean ruled by scorpion-like predators of such enormous size. But for nearly 200 million years, these creatures thrived. They shaped ecosystems in ways that echo even today. The Ordovician also saw an extraordinary expansion of biodiversity. Coral reefs began to spread. They were built by the ancestors of modern corals and sponges. Fish, which were still jawless at this stage, began to appear in greater numbers. They were covered in bony plates for defense. Though they were small and vulnerable compared to the monstrous cephalopods and Eurypterids, these early fish marked the first steps toward vertebrate dominance. Trilobites continued to flourish, but they too faced new pressures from predators that were more advanced than those of the Cambrian. The balance of survival was constantly shifting. Each new innovation pushed life into new forms of adaptation. The Silurian period, beginning around 443 million years ago, was a time of recovery and renewal. It followed the Ordovician mass extinction. That was an event that had wiped out nearly 85% of all marine species. It was likely caused by a dramatic and sudden ice age. Those that survived evolved to reclaim the oceans. Eurypterids grew even larger. They diversified into new shapes and new ecological roles. Some developed flattened bodies to glide across the seafloor. Others became streamlined, efficient swimmers. Their dominance was unmatched. In many ecosystems, they remained the top predators unchallenged for millions of years. To imagine walking along a Silurian shoreline would be to see massive sea scorpions crawling in the surf. Their armored bodies would be gleaming in the sunlight. The waters beyond would be teeming with giant cephalopods gliding silently in pursuit of prey. At the same time, jawed fish began to appear for the very first time. These were the placoderms. They were covered in heavy armor. They were still small in the Silurian, but they represented a major turning point. Jaws allowed for more efficient feeding. This opened up new strategies for both predation and defense. Though they were insignificant compared to the Eurypterids and cephalopods, at first these fish planted the evolutionary seeds that would later grow into sharks and bony fish. These new groups would eventually overtake the invertebrates that had ruled for so long. The balance of power was slowly shifting, though the giants of the Silurian could not have foreseen their eventual decline. The landscapes of the Silurian were also changing. Vascular plants, those with specialized tissues to transport water and nutrients, began to spread more widely. They grew taller than their moss-like ancestors. Small forests of primitive plants appeared along the coastlines. They created the first true terrestrial ecosystems. With them came more arthropods. They fed on decaying plant matter, and they preyed on one another in miniature dramas played out on land. Though they were tiny compared to their aquatic relatives, these land dwellers were pioneers. They were testing the possibilities of life beyond the sea. Eurypterids, Orthoceras, and their contemporaries represent a world that is both alien and foundational. They were creatures that pushed the boundaries of size and predation long before the dinosaurs or even large reptiles appeared. Their dominance reveals an important truth about Earth's history. Terrifying predators did not begin with the dinosaurs. Long before the first thunderous footsteps shook the ground, long before the skies were filled with pterosaurs or the seas with mosasaurs, The planet belonged to scorpion-like monsters and towering shell-bearing cephalopods. These animals were no less terrifying in their own right. They ruled ecosystems with a power and size that defied imagination. The Ordovician and Silurian periods remind us that the conquest of Earth was gradual and complex. While the oceans remained the primary stage, the first hints of terrestrial expansion foreshadowed the revolutions to come. Plants would eventually blanket the continents, insects would swarm in the forests, and vertebrates would crawl from the water to dominate the land. But it began humbly with creeping arthropods and tiny mosses along damp shores. All of this was observed by the shadows of Eurypterids towering in the waves. As the Silurian drew to a close and the Devonian loomed, the stage was set for yet another age of monsters. Fish would grow into armoured titans, amphibians would take their first true steps on land, and the world would once again be reshaped by predators and prey. Yet the memory of the sea scorpions and the giant cephalopods endured. They had shown what it meant to dominate an environment. They had shown how to adapt into forms of unimaginable scale. And though they would one day vanish into extinction, their legacy remained etched in the evolutionary path of all that followed. The Devonian period ended with waves of extinctions that cleared out ecosystems and reshaped the planet's future. As life recovered, the Carboniferous period began around 359 million years ago. It unfolded as one of the most extraordinary chapters in Earth's history. It was a time of immense swamps, towering forests, and a world bathed in unusually high oxygen levels. This unique combination created ecosystems unlike any seen before or since. They were filled with strange amphibians, pioneering reptiles, and insects of terrifying size. The Carboniferous was not just an age of lush vegetation, it was the age of giants. It was a time when even the air itself encouraged life to grow beyond the limits we know today. The most striking feature of this period was its landscape. Vast, swampy forests stretched across the equatorial regions. They were dominated by giant lycopods, horsetails, and seed ferns. Some of these primitive plants grew to heights of over 30 meters. They formed dense canopies above tangled wetlands. Their remains, buried over millions of years, would eventually transform into the vast coal deposits that still fuel our industries today. This is why it is called the Carboniferous period. These forests were humid, hot, and teeming with life. Their still waters provided nurseries for amphibians. Their trunks and branches created labyrinths where arthropods crept and fluttered. It was an ecosystem that was at once alien and familiar, lush and dangerous. The air itself was different. Oxygen levels soared to nearly 30 to 35%. This is compared to just 21% today. This surplus of oxygen supercharged respiration. It allowed organisms to grow to extraordinary sizes. Dragonflies, which today stretch only a few inches across, reached wingspans of nearly 70 centimeters. These giants, known as Meganeura, were aerial predators. They would swoop down to snatch smaller insects with their crushing jaws. To imagine walking through a Carboniferous swamp is to picture the shadows of dragonflies as wide as hawks passing overhead. Their wings would be beating loudly through the thick, oxygen-rich air. For smaller creatures, there was no safety from these predators. Their sheer size was made possible only by the unique atmosphere of their time. On the forest floor and within its murky waters, amphibians thrived. Many of them grew to enormous lengths. They resembled a mix of modern salamanders and crocodiles. Some reached several meters in length. They had broad skulls filled with sharp teeth perfectly adapted for ambushing prey. They lurked in the rivers and swamps waiting. They waited for fish insects or smaller amphibians to come within reach. Their semi-aquatic lifestyle allowed them to dominate both land and water. Among them was Eriops. It was a hulking predator that could grow over 2 meters long. It lumbered on strong legs, but always stayed close to the water's edge. Amphibians like Eriops defined much of the Carboniferous. They ruled the wetlands in ways unmatched by any single group of animals before them. The waterways of the Carboniferous were no less dangerous. Armoured fish, which were remnants of the Devonian, still swam in the rivers and lakes, but they were gradually giving way to more advanced species. Sharks began to diversify, taking on new forms and new ecological roles. Some, like Stethocyanthus, bore bizarre dorsal fins that were shaped like an anvil. Their purpose remains debated by scientists. Others grew larger and became more efficient hunters. They set the stage for the long evolutionary success of sharks. The rivers and swamps were therefore hunting grounds, not just for amphibians, they were also home to increasingly sophisticated fish and cartilaginous predators. These waters represented evolutionary experimentation at its height. The interplay of the plants and the atmosphere shaped much of what made the Carboniferous unique. The dense forests pumped vast amounts of oxygen into the air. At the same time, they pulled carbon dioxide from the atmosphere. The result was a cooling climate. It eventually tipped into a period of glaciation at the period's end. But during its height, the Carboniferous offered an environment of incredible abundance. Enormous insects thrived not just because of the oxygen. It was also because predators had not yet evolved the sophisticated lungs and circulatory systems to compete with them in size. It was a brief window in time in which arthropods could expand into giants. It was a window that would close when reptiles and later birds and mammals developed more efficient respiratory systems. Gigantism in insects would never again return to the scale of the Carboniferous. The ecosystems of this period were complex and layered. At the top were the giant dragonflies and the large amphibian predators. Beneath them, swarms of smaller insects buzzed among the towering plants. Reptiles scurried through the underbrush, experimenting with independence from water. On the forest floor, the colossal Arthropleura, a giant millipede, moved slowly but steadily. It consumed decaying vegetation and shaped the carbon cycle. All of it existed within a world dominated by swamps, a world where every step might sink into the mud, and a world where every shadow might conceal something larger than expected. It was a time when life's scale and abundance seemed limitless. The end of the Carboniferous marked a profound transition in Earth's history. The vast swamp forests that had defined the age began to collapse under shifting climates. And with them, the colossal insects and amphibians that had thrived in the humid, oxygen-rich conditions started to fade. In their place rose a new lineage of creatures. They were more resilient, more adaptable, and they were destined to dominate terrestrial ecosystems for millions of years. These were the synapsids. They are sometimes called mammal-like reptiles, though they were neither true reptiles nor mammals. They represented an entirely distinct branch of evolution. It was one that would eventually give rise to all mammals, including us. But long before that, the synapsids ruled the land as the fiercest predators and the most versatile survivors of the Permian period. The Permian began around 299 million years ago. It was a time when the supercontinent of Pangaea stretched across much of the globe. Its vast interior created arid deserts and extreme climates. This was unlike the swampy Carboniferous world that had come before. The collapse of the great coal forests had reduced oxygen levels, bringing them closer to modern concentrations. The giant insects and amphibians that once towered over the forests were now rare. Life faced new challenges, and those that adapted to the drier conditions would inherit the earth. Reptiles, with their amniotic eggs and water-conserving adaptations, found themselves better suited for this harsher environment, and among them, the synapsids flourished. The most iconic of these early synapsids was Dimetrodon. It was a predator that grew up to 4 meters long. It was easily one of the largest carnivores of its time. Its most striking feature was the great sail on its back. This sail was formed by elongated spines that were connected by skin. The purpose of this sail remains debated. Some scientists believe it regulated body temperature by absorbing or releasing heat. Others suggest it was a display structure used to intimidate rivals or to attract mates. Whatever its function, Dimetrodon was a fearsome hunter. It was armed with sharp, serrated teeth that were capable of shearing flesh. It stalked its prey with the confidence of an apex predator. This was a role it held for millions of years. Though it is often mistaken for a dinosaur in the popular imagination, Dimetrodon lived long before the first dinosaur appeared. It was part of the lineage that would ultimately lead to mammals. Synapsids were not just predators. Herbivorous forms also flourished. Some grew large and were heavily built to graze on the tough vegetation of the Permian landscapes. Edaphosaurus, a plant-eating relative of Dimetrodon, also bore a sail, though it was smaller and covered in crossbars. Its teeth were adapted for grinding plants. This shows how synapsids had diversified into multiple ecological roles. This adaptability made them the dominant land animals of the Permian. They filled niches from top predators to bulky herbivores. In many ways, they foreshadowed the later dominance of the dinosaurs. But in this earlier age, it was the synapsids that reigned supreme. The seas of the Permian were equally dramatic. They were populated by predators that were no less strange. Among them was Helicoprion. It was a shark-like fish whose lower jaw carried a bizarre spiral of teeth. It resembled a buzzsaw. This whirl of teeth grew continuously, curling as new teeth formed. This created one of the most unusual adaptations in vertebrate history. How Helicoprion used this strange structure remains debated. Some suggest it sliced its prey like a circular saw. Others argue it helped to grip slippery animals. Regardless of its exact function, Helicoprion was a terrifying predator. Its jaws were lined with a spiral blade that no prey could easily escape. The oceans of the Permian were testing grounds for evolutionary experiments that were as extreme as those on land. While synapsids and other reptiles thrived, the Permian world was also one of instability. The vast size of Pangaea created extreme climate zones. The interior deserts baked under a relentless heat. Coastal regions endured seasonal monsoons. The ecosystems were diverse but fragile. They were dependent on delicate balances of rainfall and vegetation. It was within this volatile context that Earth would endure the most devastating extinction in its history. Around 252 million years ago, at the end of the Permian disaster struck, it was on a scale that reshaped life forever. The cause of the Permian-Triassic extinction, often called the Great Dying, remains one of the most studied mysteries in paleontology. The leading explanation involves massive volcanic eruptions in what is now Siberia. These eruptions released enormous quantities of lava, ash, and gases into the atmosphere. This happened over hundreds of thousands of years. Carbon dioxide levels soared, driving global warming and acidifying the oceans. Methane released from seafloor deposits may have compounded the crisis further, destabilizing the climate systems. Oxygen levels in the seas plummeted, suffocating marine life. Temperatures on land rose to extremes that few organisms could survive. The result was catastrophic. An estimated 90% of marine species and 70% of land species vanished. It was the most severe mass extinction event in the history of the planet. The extinction swept away entire lineages that had dominated the Permian world. Trilobites, which were survivors of hundreds of millions of years, disappeared forever. Many of the synapsids that had once ruled as apex predators were wiped out. Coral reefs collapsed and the oceans became barren. On land, forests withered under the stress of the climate extremes. Deserts spread across Pangaea's vast interior. Ecosystems collapsed at every single level. They left behind a planet that seemed almost empty. Recovery would take millions of years. And in the aftermath, life had to reinvent itself. Yet some creatures survived. Among them were small, hardy synapsids, such as Lystrosaurus. It was a stocky, tusked herbivore that could burrow to escape the extreme conditions. Lystrosaurus became one of the most common animals of the early Triassic. It dominated landscapes that were otherwise sparsely populated. Its success shows that survival in times of crisis often favors generalists. These are creatures capable of enduring harsh environments and feeding on tough, low-quality food. While the mighty Dimetrodon and its kin perished, Lystrosaurus carried the synapsid lineage through the Great Dying. The extinction also opened the door for a new group of reptiles. These were the archosaurs. This lineage included the ancestors of crocodiles, pterosaurs, and eventually the dinosaurs. In the devastated ecosystems of the Triassic, the archosaurs diversified rapidly. They filled the niches that were left empty by the collapse of synapsid dominance. Their more upright posture, their efficient breathing systems, and their adaptability gave them advantages in the recovering world. Though the early dinosaurs were small and unremarkable compared to the later giants, their presence marked the beginning of a new era. By the late Triassic, they were rising to prominence. They were setting the stage for the Jurassic Age of dinosaurs. The story of the Permian is therefore one of triumph and tragedy. Synapsids rose to extraordinary heights. They created some of the most iconic predators and herbivores of deep time. They showcased adaptations that foreshadowed the evolution of mammals. They had advanced teeth sails for thermoregulation and a greater independence from water. But the Great Dying cut short their dominance. It left only a few survivors to carry their legacy forward. The extinction itself underscores the fragility of life on Earth. It shows how even the mightiest creatures can be swept away by forces beyond their control. It was not survival of the strongest, but survival of the most adaptable. And yet, in a deeper sense, the synapsids never truly disappeared. While their reign as the dominant land animals ended, their lineage endured quietly. Over millions of years, some of their descendants evolved into true mammals. They carried forward traits that were first pioneered in the Permian. The sail-backed Dimetrodon may be long gone, but its distant relatives would one day walk upright, think, and reshape the planet in ways no creature before had ever done. The story of the synapsids is therefore not just about extinction, it is about continuity. It is about how survival through catastrophe laid the foundation for the mammals that would one day inherit the Earth. The dawn of the dinosaurs emerging from the ashes of the Permian extinction was not an inevitable outcome. It was the result of chance, survival, and opportunity. Had the synapsids not been so devastated, perhaps their dominance might have continued unbroken, and perhaps the dinosaurs might never have risen at all. Instead, the extinction reshuffled the evolutionary deck. It cleared ecological space for the archosaurs to ascend. From there, the stage was set for the great age of reptiles, the Jurassic and the Cretaceous. This was when dinosaurs would rule the land, pterosaurs would rule the skies, and marine reptiles would rule the oceans. But before all of that, it was the synapsids, not the dinosaurs, that once commanded the Earth. To reflect on the Permian world is to glimpse both the heights of evolutionary experimentation and the depths of extinction's power. It was an age where sail-backed predators prowled the deserts. It was an age where buzzsaw jaws sliced through ocean prey. And it was an age where reptilian pioneers laid the groundwork for future dominions. It ended in disaster, but not without leaving an indelible mark on the story of life. The rise and fall of the synapsids remind us that Earth's history is not a straight line. It is a cycle of dominance, collapse, and renewal. Each extinction reshapes the path forward, and each survivor carries the seeds of tomorrow's diversity. Today, when we look at mammals, creatures that nurse their young, regulate their temperature, and think with complex brains, we see the distant echoes of the Permian synapsids. Their sails, their tusks, and their serrated teeth were once symbols of power. Now, their true legacy lies in the quiet heartbeat of every mammal that walks the Earth. The Permian may have ended in devastation, but it also marked the beginning of a new story. It was one that would lead to dinosaurs, to mammals, and ultimately to us. In the ashes of the Great Dying, life did not end. It transformed, as it always has, into something new. Earth's story begins over 4 billion years ago. The planet was a hostile world of molten rock. Violent volcanic eruptions scarred its surface. Meteors fell in a constant fiery rain. Yet within this chaos, a profound transformation was stirring. The first chemical reactions in primordial oceans sparked the origin of life. These were not grand events. They were silent, microscopic beginnings in the warm, chemical-rich waters. The earliest organisms were simple, microscopic, and single-celled. They were prokaryote cells without a nucleus, the most basic form of life imaginable. They thrived in shallow seas and near hydrothermal vents. These vents were cracks in the ocean floor, spewing superheated water and minerals. They were oases of chemical energy in a dark, deep world. These microbes left behind some of the oldest fossils known today. They are called stromatolites. Stromatolites are layered structures built by colonies of photosynthetic bacteria. Imagine vast, shallow bays covered in slimy green-blue mats. These mats were colonies of cyanobacteria. Day after day, they trapped sediment in their sticky layers. Slowly, over thousands of years, these layers built up into dome-like structures. These tiny architects transformed the atmosphere itself. Through photosynthesis, they released oxygen as a waste product. At first, this oxygen was toxic to most other life forms. It caused the planet's first great pollution event and its first mass extinction. Iron dissolved in the oceans, rusted and settled to the seafloor. This created the vast banded iron formations we mine today. But over billions of years, oxygen levels began to rise in the atmosphere. This gas would eventually allow larger, more complex creatures to evolve. It set the stage for a world powered by respiration. For most of the Precambrian era, life remained invisible to the naked eye. It was a world ruled by microbes. They quietly adapted and spread across the oceans, diversifying in unseen ways. The leap from simple prokaryotic cells to more complex eukaryotic cells was a pivotal moment. A eukaryotic cell has a nucleus and other specialized compartments called organelles. This complexity allowed for greater efficiency and specialization. It was like moving from a one-room workshop to a sprawling factory. This innovation occurred through a process called endosymbiosis. One simple cell engulfed another, but instead of digesting it, they formed a partnership. The engulfed cell became a mitochondrion, the powerhouse of the new complex cell. This single event happening billions of years ago made all complex life possible. Then, around 600 million years ago, an extraordinary shift occurred. The world was emerging from a period of intense cold known as Snowball Earth. Glaciers that had once covered the planet from pole to pole were retreating. The oceans were once again open and filled with nutrients. During the Ediacaran period, strange soft-bodied creatures emerged. They were unlike anything alive today. They floated, crawled, or attached themselves to the seafloor. They formed the first true animal communities. Fossils from this time are preserved as impressions in sandstone. They were first discovered in the Ediacara Hills of Australia by a geologist named Reg Sprigg in the 1940s. At first, scientists were baffled. Were they plants, fungi, or animals? Or something else entirely, a failed kingdom of life? These fossils revealed jellyfish-like forms, disc-shaped organisms like Dickinsonia. Dickinsonia was a flattened, quilted oval that could grow up to a meter long. It seemed to crawl along the seabed, absorbing nutrients through its body. It had no mouth, no gut, no obvious organs. Other fossils showed frond-shaped organisms swaying like plants. These creatures, known as Charnia, were anchored to the seafloor. They looked like ferns, but they lived in deep water where no sunlight could reach. They must have filtered nutrients directly from the water column. There were also flattened, quilted shapes that puzzle scientists even now. They represent an evolutionary experiment with body plans. Life was trying out new forms, new symmetries, new ways of being. This was a dress rehearsal for the complexity that was to come. While many of these species vanished, they represented an important step. They were the first large multicellular organisms. They paved the way for complex ecosystems. They set the stage for one of the most dramatic evolutionary events in history. That event was the Cambrian explosion. It began around 541 million years ago. In just a few tens of millions of years, a geological blink of an eye, the oceans filled with life. An astonishing variety of creatures appeared, each experimenting with new designs. This was not an explosion in the literal sense. It was an explosion of diversity of evolutionary innovation. For the first time, animals developed hard parts. Shells, skeletons, and teeth appeared in the fossil record. Predators with sharp claws and advanced eyes emerged. Alongside them, armored prey evolved spines and shells. This was the beginning of an evolutionary arms race. Survival now depended not just on finding food, but on avoiding becoming food. This period set the foundation for nearly every major animal group we know today. The blueprints for arthropods, mollusks, vertebrates, and more were all laid down, from the silent beginnings of microbial mats to the strange alien forms of the Ediacaran, and finally to the bustling diversity of the Cambrian seas. Life on Earth had moved from simple beginnings. It had arrived at the edge of a terrifying new age of predators. The quiet, peaceful world of the microbes was gone forever. The planet had awakened, and the story of monsters had truly begun. The Cambrian explosion remains one of the greatest puzzles in the history of life. Why did evolution suddenly shift into high gear? There was no single cause. Instead, it was a perfect storm of environmental, genetic, and ecological factors. A complex interplay of triggers that unleashed life's creative potential. The stage had been set over billions of years, and now the play could begin. Oxygen levels in the oceans had risen significantly. This was the legacy of the cyanobacteria, the silent architects of the Precambrian. More oxygen enabled higher metabolic activity. It provided the energy required for larger bodies for movement and for predation. It was like adding a supercharger to the engine of life. The breakup of supercontinents also played a critical role. As land masses drifted apart, new shallow marine environments were created. These sunlit continental shelves were rich in nutrients, perfect nurseries for evolution. Genetic innovations were equally important. The development of Hox genes, a set of master regulator genes, was a game changer. Hox genes control the basic body plan of an organism. They determine where the head, tail, and limbs should go. Think of them as the master blueprint for an architect. With this new genetic toolkit, organisms could experiment with new forms more rapidly. A small mutation in a Hox gene could lead to a dramatic change in body structure. This allowed for the rapid diversification we see in the Cambrian. And then there was the rise of predation. The moment one organism evolved the ability to hunt another, the rules changed. A relentless pressure for adaptation was created. Prey needed to develop defenses like shells and spines. Predators in turn needed to evolve better ways to hunt like sharper claws and better eyes. This feedback loop of adaptation and counter-adaptation is the engine of the arms race. It drove evolution forward at an unprecedented speed. Together, these forces unleashed a cascade of evolutionary possibilities. The result was the burst of life we now call the Cambrian explosion. The oceans once home only to microbes and strange soft-bodied drifters were transformed. They became arenas of survival filled with monsters both terrifying and alien. A world that was dynamic, dangerous, and dazzlingly diverse. The oceans of the Cambrian were vastly different from the world we know now. Shallow continental shelves stretched across much of the planet. They were bathed in sunlight and rich in nutrients from continental runoff. These conditions created fertile grounds for life to experiment with new forms. Trilobites, perhaps the most iconic Cambrian creatures, crawled along the seafloor. They appeared in massive numbers, a cornerstone of the new ecosystems. Their segmented, armored bodies provided protection from predators. They could roll up into a ball like a modern pillbug to shield their soft undersides. Their compound eyes were among the earliest advanced visual systems. Made of calcite crystals, these lenses gave them a panoramic view of their surroundings. They gave them an edge in detecting danger, or perhaps in finding food. Trilobites were not small curiosities. They came in a wide range of sizes. Some were only a few centimeters long. Others were giants, more than half a meter in length. They filled multiple roles as scavengers, grazers, and prey. They were the workhorses of the Cambrian seas. Yet trilobites were far from the most fearsome creatures of their time. That title belonged to predators like Anomalocaris. Its very name means abnormal shrimp, and for good reason. When its fossils were first discovered, they were found in pieces. Scientists initially thought its grasping appendages were the bodies of shrimp. They believed its circular mouth was a fossilized jellyfish. Only later, when a complete fossil was found, did they realize their mistake. They had been looking at different parts of the same colossal creature. Reaching lengths of up to 1 meter, Anomalocaris was a giant for its time. This beast was equipped with 2 spiny, grasping appendages at the front of its body. With them, it snatched up trilobites and other prey. It would then bring them to its circular toothed mouth. This mouth, a ring of sharp plates, could crush the hard shells of its victims. Its large, stalked eyes contained thousands of lenses. This gave Anomalocaris exceptional vision, making it one of the most advanced hunters of its age. Swimming gracefully with undulating flaps along its body, it patrolled the seas. Anomalocaris embodied the dawn of active predation, a shift that transformed life into a brutal struggle for survival. The Cambrian seas were also home to a menagerie of other strange creatures. Many were discovered in the Burgess Shale, a fossil site in the Canadian Rockies. This site, discovered by paleontologist Charles Doolittle Walcott in 1909, is a window into the Cambrian world. The fine-grained mud of an ancient seafloor preserved soft-bodied animals in exquisite detail. For decades, Walcott painstakingly excavated thousands of fossils. He worked tirelessly, often with his family, to unearth this lost world. but the creatures he found were so bizarre he struggled to classify them. He tried to fit them into existing animal groups, sometimes forcing them into ill-fitting categories. It wasn't until generations later that scientists like Simon Conway Morris re-examined the fossils. They realized these were not just oddities. They were representatives of entirely new body plans, evolutionary experiments that have no modern equivalent. Creatures like Waiwaxia, covered in long defensive spines, and Hallucigenia with its bizarre array of spiky protrusions. These creatures looked almost otherworldly, but their unusual designs were functional defenses in a dangerous world. Hallucigenia, a worm-like creature no longer than a finger, baffled researchers for decades. It appeared to walk on thin, spindly legs while sporting rows of spikes along its back. For a long time, paleontologists even displayed it upside down. They mistook its back spines for legs and its legs for tentacles. The fossil was so strange it seemed to defy logic. The name Hallucigenia reflects this dreamlike, bizarre quality. Despite its odd appearance, it was an important part of the Cambrian ecosystem. It represents the early stages of evolutionary experimentation. Life was trying out new ideas for body symmetry, locomotion, and defense. Its lineage, though bizarre, would eventually contribute to the arthropods. This is the group that includes insects, spiders, and crustaceans today. The Cambrian seas also hosted a variety of armored worms and early mollusks. Waiwaxia, with its leaf-like scales and sharp dorsal spines, may have scraped algae from surfaces. It survived more by defense than offense. Then there was Picaia, a small eel-like swimmer. It is particularly important because it is one of the earliest known chordates. Chordates are animals with a notochord, a flexible rod that provides support. This structure is the precursor to the vertebral column, the backbone. Though only a few centimeters long, Picaia represents the humble beginnings of our own lineage. It is a distant ancestor to fish, reptiles, mammals, and humans. In the shadow of monstrous predators and armored invertebrates, the first stirrings of vertebrate ancestry quietly unfolded. We owe our existence to this small, unassuming swimmer. If Picaia had not survived the perilous Cambrian seas, our own story might never have begun. The Cambrian explosion was a pivotal moment. It established the fundamental body plans that would shape animal evolution for the next 500 million years. It turned the oceans from a quiet realm of microbes into a dynamic, bustling world. It introduced the brutal logic of predation, a force that continues to drive evolution today. The monsters of the Cambrian were not just terrifying, they were pioneers, innovators, and the architects of the modern animal kingdom. As the Cambrian explosion waned, life on Earth did not slow its pace. The Ordovician period began around 485 million years ago. The seas became even more crowded, filled with new predators and prey. Evolution was pushed forward in extraordinary ways. The oceans spread widely across the planet. They were shallow and warm, creating vast habitats teeming with opportunities. In these waters, invertebrates continued to dominate, but their forms grew stranger, larger, and more lethal. Among them rose some of the most terrifying hunters Earth had ever seen, giant squid-like cephalopods with towering shells, sea scorpions as long as a human, and the first daring creatures that crawled from water onto the uncharted frontier of land. The Ordovician seas were ruled by cephalopods. These were distant ancestors of today's squids and octopuses. Unlike their modern relatives, many carried long conical shells. These shells, called orthocones, gave them both protection and buoyancy. By adjusting the gas in the chambers of their shells, they could control their depth. They moved using jet propulsion, forcing water out of a siphon. The largest of them, Camaraceras, could grow to several meters in length. It was one of the most formidable predators of its age. Imagine a submarine of flesh and bone gliding silently through the water, tentacles stretched out from its shell searching for prey. Its sharp, beak-like jaws could crush the shells of trilobites. Smaller animals stood little chance once ensnared by its grasping arms. Their sheer size alone meant that few creatures could challenge them. For millions of years they reigned as apex predators of the Ordovician seas. They were the first true giants of the animal kingdom. While cephalopods hunted in open waters, another group of monsters lurked in the shallows. These were the Eurypterids, better known as sea scorpions. They were arthropods, relatives of scorpions, spiders, and crabs, but their scale dwarfed anything of their lineage alive today. Some species grew over 2.5 meters long. This makes them the largest arthropods to ever exist. With their clawed appendages, paddle-like limbs, and armored bodies, they were formidable. Eurypterids prowled coastal environments with unmatched dominance. Some swam with surprising agility, using their rear paddles to propel themselves. Others may have stalked prey along the seafloor like giant underwater scorpions. Their powerful pincers could crush fish and invertebrates alike. Their sheer presence turned the shallows into places of dread. It is difficult to imagine an ocean ruled by scorpion-like predators of such enormous size. But for nearly 200 million years, these creatures thrived. They shaped ecosystems in ways that echo even today. The Ordovician also saw an extraordinary expansion of biodiversity. This event is known as the Great Ordovician Biodiversification Event. Coral reefs began to spread, built by the ancestors of modern corals and sponges. These reefs created complex three-dimensional habitats. They provided shelter and food for countless other species. The oceans were becoming more structured, more like the ecosystems we know today. Fish, still jawless at this stage, began to appear in greater numbers. They were covered in bony plates for defense against the giant predators. Creatures like Astraspis were small and slow-moving. They likely grubbed for food in the sediment on the seafloor. Though vulnerable compared to the monstrous cephalopods and eurypterids, they were significant. These early fish marked the first steps toward vertebrate dominance. Trilobites continued to flourish, diversifying into thousands of species. But they too faced new pressures from predators more advanced than those of the Cambrian. The balance of survival was constantly shifting. Each innovation in predation was met with an innovation in defense. Evolution was a relentless cycle of move and countermove. The Silurian period, beginning around 443 million years ago, was a time of recovery. It followed the Ordovician mass extinction. This event had wiped out nearly 85% of marine species. It was likely caused by a dramatic ice age that lowered sea levels and temperatures. Those that survived evolved to reclaim the oceans. Eurypterids grew larger, diversifying into new shapes and roles. Some, like Pterygotus, developed massive claws for crushing armored prey. Others became streamlined swimmers, chasing down fish in open water. Their dominance was unmatched. In many ecosystems, they remained the top predators unchallenged for millions of years. To imagine walking along a Silurian shoreline is to see a nightmare landscape. Massive sea scorpions crawling in the surf, their armored bodies gleaming. The waters beyond teeming with giant cephalopods gliding silently in pursuit of prey. At the same time, a revolutionary new development was occurring among the vertebrates. Jawed fish began to appear for the first time. This innovation, the evolution of the jaw, was a turning point in history. Jaws likely evolved from the gill arches that supported the gills of jawless fish. This new structure allowed for more efficient feeding. It opened new strategies for both predation and defense. Placoderms, a group of armored fish, were among the first to have jaws. They were still small in the Silurian, but they represented a major shift. Though insignificant compared to eurypterids and cephalopods at first, they planted a seed. These fish were the ancestors of the great vertebrate predators to come. Sharks and bony fish would later evolve from these humble beginnings. Eventually, vertebrates would overtake the invertebrates that had ruled for so long. The balance of power was shifting, though the giants of the Silurian could not have seen it. The landscapes of the Silurian were also changing. This was the era when life truly began to conquer the land. Vascular plants, those with specialized tissues to transport water and nutrients, began to spread. Creatures like Cooksonia were among the first. They were small, only a few centimeters tall, with simple branching stems. They grew in damp areas along coastlines. They formed the first true terrestrial ecosystems. With them came the first land animals. Arthropods, already successful in the sea, were the pioneers. Millipede-like creatures and early arachnids crept among the primitive plants. They fed on decaying plant matter and preyed on one another in miniature dramas. Though tiny compared to their aquatic relatives, these land dwellers were pioneers. They were testing the possibilities of life beyond the sea. They faced immense challenges, the risk of drying out the need to breathe air, the pull of gravity. But they adapted, laying the groundwork for the vast terrestrial ecosystems to come. The monsters of the Ordovician and Silurian represent a world both alien and foundational. Eurypterids, orthocones, and their contemporaries pushed the boundaries of size and predation. They did so long before dinosaurs or even large reptiles appeared. Their dominance reveals an important truth about Earth's history. Terrifying predators did not begin with dinosaurs. Long before the first thunderous footsteps shook the ground, long before the skies were filled with pterosaurs or the seas with mosasaurs, the planet belonged to scorpion-like monsters and towering shell-bearing cephalopods. These animals were no less terrifying in their own right. They ruled ecosystems with power and size that defied imagination. The Ordovician and Silurian periods remind us that the conquest of Earth was gradual. It was complex and filled with strange and monstrous pioneers. While the oceans remained the primary stage, the first hints of terrestrial expansion foreshadowed revolutions. Plants would eventually blanket continents, insects would swarm in forests, and vertebrates would crawl from water to dominate the land. But it began humbly with creeping arthropods and tiny mosses along damp shores. Perhaps observed by the shadows of Eurypterids towering in the waves. As the Silurian drew to a close and the Devonian loomed, the stage was set. Another age of monsters was about to begin. Fish would grow into armoured titans. Amphibians would take their first true steps on land. The world would once again be reshaped by predators and prey. Yet the memory of the sea scorpions and giant cephalopods endured. They had shown what it meant to dominate an environment. They had adapted into forms of unimaginable scale. And though they would one day vanish into extinction, their legacy remained. It was etched in the evolutionary path of all that followed. The Devonian period is often called the Age of Fishes, and for good reason. The small-jawed placoderms of the Silurian evolved into titans. The oceans and rivers of the Devonian teemed with armoured predators of terrifying proportions. Among the most fearsome was Dunkleosteus. This was a placoderm that could grow up to 6 meters long. It was not armed with teeth. Instead, its jaws were lined with sharp, bony plates that functioned like a guillotine. Its bite force was among the most powerful of any animal ever. It could shear through the armour of other fish, and even its own kind. Dunkleosteus was the apex predator of the Devonian seas, a true monster. While fish ruled the waters, the conquest of land was accelerating. Plants evolved seeds, allowing them to reproduce in drier environments. Vast forests of primitive trees like Archaeopteris began to spread. These forests created new habitats with shaded interiors and rich soil. This set the stage for the next great evolutionary leap. From the water emerged the first tetrapods, 4-limbed vertebrates. Creatures like Tiktaalik had fins with wrist-like bones. They could prop themselves up in shallow water and perhaps even pull themselves onto land. They were a perfect transitional form between fish and amphibians. The Devonian period ended with waves of extinctions. These events cleared ecosystems and reshaped the planet's future. As life recovered, the Carboniferous period began around 359 million years ago. It unfolded as one of the most extraordinary chapters in Earth's history. It was a time of immense swamps, towering forests, and high oxygen levels. This unique combination created ecosystems unlike any seen before or since. The world was filled with strange amphibians, pioneering reptiles, and insects of terrifying size. The Carboniferous was not just an age of lush vegetation, it was the age of giants, an age when the air itself encouraged life to grow beyond the limits we know today. The most striking feature of this period was its landscape. Vast, swampy forests stretched across equatorial regions. They were dominated by giant lycophytes, horsetails, and seed ferns. Some of these primitive plants, like Lepidodendron, grew to heights of over 30 meters. They formed dense canopies above tangled wetlands. Their remains, buried over millions of years in the oxygen-poor swamps, did not fully decompose. Instead, they were compressed and transformed into the vast coal deposits that fuel industries today, hence the name Carboniferous or coal-bearing. These forests were humid, hot, and teeming with life. Their still waters provided nurseries for amphibians. Their trunks and branches created labyrinths where arthropods crept and fluttered. It was an ecosystem at once alien and familiar, lush and dangerous. The air itself was different. Photosynthesis from the immense forests pumped huge amounts of oxygen into the atmosphere. Oxygen levels soared to nearly 30 to 35%. This is compared to just 21% today. This surplus of oxygen supercharged respiration. It allowed organisms, especially those with inefficient breathing systems like arthropods, to grow to extraordinary sizes. The insects and other arthropods of the Carboniferous were giants. Dragonflies, which today stretch only a few inches across, reached wingspans of nearly 70 centimeters. These giants, known as Meganeura, were aerial predators. They swooped down to snatch smaller insects with crushing jaws. To imagine walking through a Carboniferous swamp is to picture a different world. The shadows of dragonflies as wide as hawks passing overhead, their wings beating loudly through the thick, oxygen-rich air. For smaller creatures, there was no safety from these predators. Their sheer size was made possible only by the atmosphere of their time. On the forest floor, other giant arthropods roamed. Arthropleura, a relative of modern millipedes, grew to over 2 meters long. It was a heavily armored herbivore scuttling through the undergrowth, its many legs moving in a mesmerizing wave. Giant scorpions like Pulmonoscorpius hunted for smaller prey. The air, the ground, and the water were all home to arthropod giants. In the murky waters of the swamps, amphibians thrived. Many of them grew to enormous lengths, a mix of modern salamanders and crocodiles. Some reached several meters with broad skulls filled with sharp teeth. They were perfectly adapted for ambushing prey. They lurked in rivers and swamps waiting for fish, insects, or smaller amphibians. Their semi-aquatic lifestyle allowed them to dominate both land and water. Among them was Eriops, a hulking predator that could grow over 2 meters long. It lumbered on strong legs but always stayed close to the water's edge. Amphibians like Eriops defined much of the Carboniferous. They ruled wetlands in ways unmatched by any single group of animals before them. The waterways were no less dangerous. Armored fish, remnants of the Devonians, still swam in rivers and lakes. They were gradually giving way to more advanced species. Sharks began to diversify, taking on new forms and ecological roles. Some, like Stephacanthus, bore bizarre dorsal fins shaped like an anvil. The top of the fin was covered in tooth-like denticles. Its purpose remains debated by scientists. Was it for mating displays, for defense, or for anchoring itself to the seabed? Others grew larger and more efficient, hunters setting the stage for sharks' long evolutionary success. The rivers and swamps were therefore hunting grounds for a host of predators. These waters represented evolutionary experimentation at its height. But another crucial development was taking place in the shadows of the giant amphibians. The first true reptiles appeared. They evolved from amphibian ancestors. Their key innovation was the amniotic egg. This egg, with its protective shell and membranes, allowed reptiles to lay their eggs on land. They were no longer tied to the water for reproduction. This freedom would allow them to conquer the drier environments that were to come. Early reptiles like Hylonomus were small, lizard-like creatures. They likely fed on the abundant insects of the forest floor. They were insignificant compared to the giant amphibians of their time. But they held the key to the future. The interplay of plants and atmosphere shaped much of what made the Carboniferous unique. Dense forests pumped vast amounts of oxygen into the air. They also pulled enormous amounts of carbon dioxide from the atmosphere. This carbon was locked away in the form of coal. The result was a cooling climate that eventually tipped into glaciation at the period's end. But during its height, the Carboniferous offered an environment of abundance. Enormous insects thrived not just because of oxygen. They thrived because flying predators like birds had not yet evolved. It was a brief window in which arthropods could expand into giants, a window that would close when reptiles and later birds developed more efficient respiratory systems. Gigantism in insects would never again return to the scale of the Carboniferous. The ecosystems of this period were complex and layered. At the top were giant dragonflies and amphibian predators. Beneath them, swarms of smaller insects buzzed among towering plants. Reptiles scuttled through the undergrowth, experimenting with independence from water. On the forest floor, colossal Arthropleura moved slowly but steadily. It consumed decaying vegetation and shaped the carbon cycle. All of it existed within a world dominated by swamps, a world where every step might sink into mud, and every shadow might conceal something larger than expected. It was a time when life's scale and abundance seemed limitless. A green, buzzing and dangerous paradise built on coal and oxygen. The end of the Carboniferous marked a profound transition. The vast swamp forests that had defined the age began to collapse. Shifting climates led to drier conditions. With the forests went the colossal insects and amphibians that had thrived in humid, oxygen-rich conditions. They started to fade. In their place rose a new lineage of creatures. More resilient, more adaptable, and destined to dominate terrestrial ecosystems. These were the synapsids. They are sometimes called mammal-like reptiles, though this is misleading. They were neither true reptiles nor mammals. They represented an entirely distinct branch of evolution, one that would eventually give rise to mammals, including us. But long before that, synapsids ruled the land. They were the fiercest predators and most versatile survivors of the Permian period. The Permian began around 299 million years ago. The world looked very different. The supercontinent Pangaea stretched across much of the globe. Its vast interior created arid deserts and extreme climates. This was unlike the swampy Carboniferous world that had come before. The collapse of the great coal forests had reduced oxygen levels. They were now closer to modern concentrations. The giant insects and amphibians that once towered over the forests were now rare. Life faced new challenges. Those that adapted to drier conditions would inherit the earth. Reptiles with their amniotic eggs and water-conserving adaptations were well suited for this harsher environment. Among them, the synapsids flourished. The most iconic of these early synapsids was Dimetrodon. It was a predator that grew up to 4 meters long. It was easily one of the largest carnivores of its time. Its most striking feature was the great sail on its back. This sail was formed by elongated spines connected by skin. The purpose of this sail remains a topic of scientific debate. Some scientists believe it regulated body temperature. By turning towards the sun, Dimetrodon could absorb heat quickly in the morning. By turning away, it could release excess heat. This would have given it an advantage over its cold-blooded prey. Others suggest it was a display structure. It could have been used to intimidate rivals or attract mates. A larger, more colourful sail might signal a healthier, more dominant individual. Whatever its function, Dimetrodon was a fearsome hunter. It was armed with sharp, serrated teeth of different sizes. This is a trait known as heterodonty that we see in mammals today. It allowed for more specialised feeding. Dimetrodon could shear flesh with some teeth and grip with others. It stalked its prey with the confidence of an apex predator, a role it held for millions of years. Though often mistaken for a dinosaur in popular imagination, Dimetrodon was not a dinosaur. It lived and died out long before the first dinosaur appeared. It was part of our own lineage, the lineage that would ultimately lead to mammals. Synapsids were not just predators. Herbivorous forms also flourished. Some grew large and heavily built to graze on the tough vegetation of the Permian landscapes. Edaphosaurus, a plant-eating relative of Dimetrodon, also bore a sail. Its sail was smaller and covered in bony crossbars. Its teeth were adapted for grinding plants, not slicing flesh. This shows how synapsids had diversified into multiple ecological roles. This adaptability made them the dominant land animals of the Permian. They filled niches from top predators to bulky herbivores. In many ways, they foreshadowed the later dominance of dinosaurs, but in this earlier age, it was synapsids that reigned supreme. The seas of the Permian were equally dramatic. They were populated by predators no less strange. Among them was Helicoprion, a shark-like fish. Its lower jaw carried a bizarre spiral of teeth resembling a buzzsaw. This wall of teeth grew continuously. It curled as new teeth formed, pushing the older ones into the center of the spiral. This is one of the most unusual adaptations in vertebrate history. How Helicoprion used this strange structure remains debated. Some early reconstructions showed the tooth hole on its nose or tail fin. We now know it was in the lower jaw. Some suggest it sliced through soft-bodied prey like squid. Others argue it helped grip slippery animals or crush ammonite shells. Regardless of its exact function, Helicoprion was a terrifying predator. Its jaws were lined with a spiral blade that no prey could easily escape. The oceans of the Permian were testing grounds for evolutionary experiments as extreme as those on land. While synapsids and other reptiles thrived, the Permian world was one of instability. The vast size of Pangaea created extreme climate zones. Interior deserts baked under relentless heat. Coastal regions endured seasonal monsoons. Ecosystems were diverse but fragile, dependent on delicate balances. It was within this volatile context that Earth would endure its most devastating extinction. Around 252 million years ago, at the end of the Permian disaster struck, it was a catastrophe on a scale that reshaped life forever. This was the Permian-Triassic extinction, often called the Great Dying. The cause remains one of the most studied mysteries in paleontology. The leading explanation involves massive volcanic eruptions in what is now Siberia. These eruptions, known as the Siberian Traps, released enormous quantities of lava, ash, and gases. They continued for hundreds of thousands of years, covering an area larger than Western Europe. Carbon dioxide levels soared, driving runaway global warming. Ocean temperatures rose, and acid rain poured down. The oceans became acidic, dissolving the shells of marine organisms. Methane released from seafloor deposits may have compounded the crisis. This would have further destabilized climate systems. Oxygen levels in the seas plummeted, creating vast dead zones. Marine life suffocated on a massive scale. Temperatures on land rose to extremes that few organisms could survive. The result was catastrophic. An estimated 90% of marine species and 70% of land species vanished. It was the most severe mass extinction event in the history of the planet. Life on Earth came closer to being wiped out than at any other time. The extinction swept away entire lineages. Trilobite survivors of hundreds of millions of years disappeared forever. The great sea scorpions were gone. Many synapsids that had once ruled as apex predators were wiped out. Coral reefs collapsed, and the oceans became barren. On land, forests withered under the stress of climate extremes. Deserts spread across Pangaea's vast interior. Ecosystems collapsed at every level, leaving behind a planet that seemed almost empty. Recovery would take millions of years. In the aftermath, life had to reinvent itself. Yet some creatures survived. Among them were small, hardy synapsids, such as Lystrosaurus. It was a stocky, tusked herbivore about the size of a pig. It could burrow to escape extreme conditions. Lystrosaurus became one of the most common animals of the early Triassic. Its fossils are found all over the world, evidence of its widespread success. It dominated landscapes that were otherwise sparsely populated. Its success shows that survival in times of crisis often favors generalists, creatures capable of enduring harsh environments and feeding on tough, low-quality food. While the mighty Dimetrodon and its kin perished, Lystrosaurus carried the synapsid lineage through the Great Dying. The extinction also opened the door for a new group of reptiles. These were the archosaurs. This lineage included the ancestors of crocodiles, pterosaurs, and eventually dinosaurs. In the devastated ecosystems of the Triassic, archosaurs diversified rapidly. They filled niches left empty by the collapse of synapsid dominance. Their more upright posture and efficient breathing systems gave them advantages in the recovering world. Though early dinosaurs were small and unremarkable, their presence marked the beginning of a new era. By the late Triassic, they were rising to prominence. They were setting the stage for the Jurassic Age of dinosaurs. The story of the Permian is therefore one of triumph and tragedy. Synapsids rose to extraordinary heights, creating some of the most iconic predators of deep time. They showcased adaptations that foreshadowed the evolution of mammals, advanced teeth sails for thermoregulation and greater independence from water. But the Great Dying cut short their dominance. It left only a few survivors to carry their legacy forward. The extinction itself underscores the fragility of life. It shows how even the mightiest creatures can be swept away by forces beyond their control. It was not survival of the strongest, but survival of the most adaptable. And yet, in a deeper sense, the synapsids never truly disappeared. While their reign as dominant land animals ended, their lineage endured quietly. Over millions of years, some of their descendants evolved into true mammals. They carried forward traits first pioneered in the Permian. The sail-backed Dimetrodon may be long gone, but its distant relatives would one day walk upright, think, and reshape the planet. The story of synapsids is therefore not just about extinction, it is about continuity. It is about how survival through catastrophe laid the foundation for the mammals that would one day inherit the Earth. The dawn of the dinosaurs emerging from the ashes of the Permian extinction was not inevitable. It was the result of chance, survival, and opportunity. Had synapsids not been so devastated, perhaps their dominance might have continued. Perhaps dinosaurs might never have risen at all. Instead, the extinction reshuffled the evolutionary deck. It cleared ecological space for archosaurs to ascend. From there, the stage was set for the great age of reptiles. The Jurassic and Cretaceous, when dinosaurs would rule the land, pterosaurs the skies, and marine reptiles the oceans. But before all of that, it was synapsids, not dinosaurs, that once commanded the Earth. To reflect on the Permian world is to glimpse both the heights of evolutionary experimentation and the depths of extinction's power. It was an age where sail-backed predators prowled deserts, where buzzsaw jaws sliced through ocean prey, where reptilian pioneers laid the groundwork for future dominions. It ended in disaster, but not without leaving an indelible mark. The synapsids' rise and fall remind us that Earth's history is not a straight line. It is a cycle of dominance, collapse, and renewal. Each extinction reshapes the path forward. Each survivor carries the seeds of tomorrow's diversity. Today, when we look at mammals, creatures that nurse their young, regulate their temperature, and think with complex brains, we see the distant echoes of Permian synapsids. Their sails, their tusks, their serrated teeth were once symbols of power. Now their true legacy lies in the quiet heartbeat of every mammal that walks the Earth. The Permian may have ended in devastation, but it also marked the beginning of a new story. One that would lead to dinosaurs, to mammals, and ultimately to us. In the ashes of the great dying life did not end. It transformed, as it always has, into something new. Above the thin blue sky lay the vastness of space, a realm filled with wandering bodies of rock and ice. Countless asteroids, remnants of the solar system's birth, drifted silently. Their orbits were unpredictable, their paths sometimes intersecting with the fragile sphere of Earth. Through the millions of years of the Cretaceous, many smaller impacts scarred the planet. They left craters that spoke of devastation on a local scale, but none had yet brought the final curtain down upon the age of dinosaurs. The story of their end is often told with a single asteroid. But what if the truth was more complex, more terrifying? What if the heavens unleashed not one but two catastrophic blows? Scientists today study the skies with telescopes and satellites. They track the movement of these silent wanderers. They know that asteroids often travel in clusters. They are fragments of once larger bodies that shattered long ago. In the ancient past, one of these clusters could have strayed too close to Earth. It could have sent not one but two massive asteroids hurtling toward the planet. The idea is staggering. Two enormous impacts striking at nearly the same time. Their combined power far beyond anything a single asteroid could unleash. To imagine this moment, one must first picture the stillness before. In the late Cretaceous night, stars blazed across the sky. The Milky Way stretched like a band of silver. The forests of Pangaea, now broken into separate continents, lay quiet under the moonlight. Somewhere deep in these forests, small mammals scurried among the undergrowth. Their tiny hearts beat quickly as they searched for food. They were avoiding the shadows of nocturnal predators. A triceratops herd rested in the open plains. Their bulk a shield against prowling eyes, their young nestled between them. Out at sea, mosasaurs sliced through the dark water. They chased schools of fish that glittered faintly under the surface. Life went on, unaware of the doom approaching from the cosmos. High above, invisible to all eyes below, two asteroids streaked through space. They were on their final approach. One was destined for the ocean, the other for the land. Their speeds were unimaginable, tens of thousands of kilometers per hour. Faster than sound, faster than anything life on Earth could comprehend. They carried within them the power to unmake worlds. In those last moments before entry, the asteroids would have been brilliant streaks of fire. They would ignite the sky as friction with the atmosphere tore at their rocky surfaces. From the ground, creatures may have looked upward, startled by the sudden blazing light. Some may have fled, others frozen in confusion. Within seconds, the first asteroid tore through the atmosphere. It glowed like a second sun before slamming into the ocean. The sea erupted as billions of tons of water exploded upward, vaporized instantly. A wall of fire and water rose skyward. Shockwaves radiated out in all directions. A mega tsunami was born, racing away faster than any creature could hope to escape. Almost simultaneously, the second asteroid struck land. The Earth itself shook as if it were alive. It quaked violently as the ground split and buckled. Forests ignited instantly, trees snapping and collapsing under the force of the blast. Rocks melted, vaporized into plumes of ash and fire that soared into the sky. The crater was vast, a wound in the planet's surface. Its rim glowed red-hot as rivers of molten rock flowed outward. The air itself turned deadly. Shock waves ripped through the atmosphere, flattening everything in their path for hundreds of kilometers. The heat was unbearable, a searing wind that set flesh and vegetation alight in an instant. Animals within sight of the impacts would have had no chance. Even those farther away, hidden in caves or swimming deep in rivers, felt the violent tremors. They saw the sky transform into a canvas of fire and smoke. This double impact was not simply destruction. It was the beginning of transformation. The combined force of both collisions sent billions of tons of dust, ash, and rock high into the stratosphere. This material formed a blanket that encircled the globe. Sunlight struggled to penetrate this veil. Within days, the bright, warm world of the dinosaurs grew dim. The Earth, once alive with sound and color, was slipping into silence and shadow. The stage was set for extinction, but also for rebirth. This single event, two asteroids striking in unison, was a reminder. The history of life on Earth has always been shaped not only by evolution but also by chance. The dinosaurs who had ruled for more than 150 million years could not foresee their end. Yet it was written in the stars, carried by rocks that had wandered since the dawn of the solar system. The late Cretaceous Earth, vibrant and teeming with life, had no idea. Its dominance was about to be tested by forces beyond its control. The late Cretaceous Earth had no reason to expect catastrophe. Life thrived across every landscape, from the wide inland seas to the volcanic highlands and vast floodplains. The world stretched beneath warm skies, a stable paradise for the ruling dinosaurs. But far above the planet, beyond the thin veil of atmosphere, the solar system was restless. Countless asteroids drifted through the void. Silent remnants of creation, pieces of rock and iron left over from planet formation. Some followed stable paths circling the sun without incident. Others wandered, nudged by the faint pull of gravity, their courses shifting slowly, until one day they crossed the orbit of Earth. Two such bodies had been wandering for millions of years. They may have once belonged to a much larger parent asteroid, one that broke apart in a violent collision within the asteroid belt. The fragments drifted together through space, their paths so closely aligned that when their long journey finally intersected Earth, they would arrive almost side by side. This was no ordinary chance. It was the result of cosmic accidents stretching back to the dawn of time. The first asteroid was immense, several kilometers wide, a mountain of stone and metal hurtling through the void. Its surface bore the scars of countless impacts from smaller fragments. Pits and grooves were etched into it like the face of an ancient traveler. The second, slightly smaller but no less dangerous, followed closely behind. Together they carried energy beyond comprehension. Each was capable of releasing the force of millions of nuclear weapons. As they drew nearer to Earth, the planet's gravity began to pull them in. Tugging gently at first, then with increasing strength. They accelerated, moving faster than any sound, faster than any storm. Faster than the speed at which life could react. The creatures below could not see them yet, but the moment of impact was inevitable. In the prehistoric skies of the broken continents, clouds drifted lazily. Herds of hadrosaurs grazed in swampy lowlands. Their heads rose and fell as they tore vegetation from ferns and cycads. Predators lingered at the edges of the herds, their eyes watching for weakness, waiting for the moment to strike. Life carried on oblivious to what approached from above. Suddenly, far in the distance, a strange light began to glow. It started as a faint streak across the sky. Then it grew brighter, sharper, burning with an intensity unlike the familiar stars. The first asteroid was entering the atmosphere. Air compressed in front of it, heating to temperatures so high that the rock itself began to glow. It shed fragments as it tore through the upper layers of the sky. The roar would have been deafening, a sound so loud it shook the air itself. Animals turned their heads confused, some startled into running. But even as they fled, the second asteroid was following close behind. It blazed like a second sun. For a brief, terrifying moment, Earth was lit brighter than day. Shadows stretched and vanished as both fireballs streaked overhead. Their trails carved glowing scars across the heavens. In those seconds, the planet's fate was sealed. Scientists today try to imagine the rarity of such an event. A single massive asteroid strike is devastating enough. Two arriving nearly simultaneously is almost beyond calculation. Yet evidence of clustered impacts in Earth's geological record suggests such possibilities are real. Debris fields from ancient collisions show that fragments often travel together, bound by their shared history, their orbits entangled across time. Back in the Cretaceous, the twin asteroids hurtled downward. Their targets were unknowing. The larger one was on a path toward open ocean. The waters of the western interior seaway shimmered under the sun. The smaller, yet still catastrophic, was aimed for land near the coastal plains. These different targets would combine to produce devastation on a scale never before seen. In the moments before impact, the air grew hotter. Winds surged as the pressure of the falling bodies pushed against the atmosphere. Some creatures may have screamed, sensing the unnatural fury of the sky. Pterosaurs caught mid-flight may have been flung from the air by the sudden turbulence. The ground itself seemed to tremble before the strikes, as if the Earth knew what was about to happen. Then came the final descent. The asteroids plummeted at speeds exceeding 20 kilometers per second, unstoppable, inevitable. In one breathless instant, the first slammed into the ocean. The water exploded outward with unimaginable force. It rose higher than mountains as steam and spray filled the air. Shockwaves shot through the sea, killing countless marine animals instantly. A tsunami began racing across the seaway, building speed as it approached distant shores. Barely a heartbeat later, the second asteroid struck land. The explosion was blinding, hotter than the surface of the sun. Rock vaporized instantly. Soil and stone were flung skyward in a fountain of fire. The blast flattened forests in every direction, igniting them in waves of flame. Animals near the point of impact were erased in an instant. Their forms were reduced to shadows burned into stone. In that single moment, the combined arrival of the two asteroids had changed Earth forever. Their paths, written in the silence of space, had converged on this world of dinosaurs. They carried within them the seeds of destruction and the dawn of a new age. The dinosaurs had no way of knowing the forces at play above their heads. They could not see the millions of years of cosmic chance that brought these asteroids together. Yet, they were now caught in the outcome, helpless before the fury of the universe. And as the dust and fire rose into the sky, the planet itself shuddered. The moment the two asteroids struck, the world of the dinosaurs was thrown into chaos. Nothing in their 150 million years of dominance had prepared them for this scale of destruction. The double impact was unlike anything the planet had ever endured, a force so powerful it shook the very foundations of the Earth. The first asteroid slammed into the ocean with the energy of billions of tons of explosives. The sea erupted as though the surface of the planet itself had torn open. Walls of water taller than mountains rose into the air before collapsing outward. Titanic waves crashed across the sea. Fish were hurled from the water, their bodies shattered against the force. Mosasaurs and plesiosaurs, rulers of the seas, were thrown violently through currents. No creature could resist such force. The impact vaporized billions of tons of seawater in an instant. It sent a plume of steam and superheated debris into the atmosphere. The ocean floor cracked, releasing shock waves that rolled outward across the seaway. These waves shook the continental shelves. While the ocean burned and boiled, the second asteroid struck land. The explosion was instantaneous and absolute. Within the first moments of contact, the rock and soil beneath the impact melted. They were vaporized by heat greater than the surface of the sun. The crater widened in a roar of fire. Glowing rivers of molten rock sprayed outward in every direction. Forests that had stood for millions of years were flattened in an instant. Their trunks ignited like torches. Animals caught near the site vanished without a trace. Their bodies were reduced to ash before they could even register the sound of impact. The air itself turned against life. Shock waves raced outward faster than sound. They flattened everything for hundreds of kilometers. Trees splintered and snapped like brittle twigs, sending clouds of burning splinters into the sky. The pressure of the blast crushed creatures where they stood. It collapsed lungs, ruptured organs. Further away, winds screamed through the plains. A furnace-like heat followed behind. Creatures fled in panic, but no speed was enough. Herds of triceratops ran blindly across the land. Their calls were drowned in the roar of the atmosphere tearing apart around them. Packs of dromaeosaurs darted through forests already ablaze. Their keen instincts offered no escape from the suffocating smoke and fire. Across the continent, the force of the ocean impact reached shore. Waves the size of mountains thundered across the coastline. They tore entire forests from their roots, dragging herds of dinosaurs into the sea. Giant reptiles that once ruled the water were flung onto land. Their immense bodies were shattered by the weight of collapsing waves. Rivers flooded backward, their currents reversed as water surged inland. The water carried debris, sand, and living creatures alike. As the twin explosions' fury spread, the sky itself began to change. Fireballs rained down across thousands of kilometers. These were fragments of molten rock hurled into the atmosphere before crashing back to Earth. Each impact sparked wildfires, igniting grasslands, forests, and swamps. The flames merged into infernos that consumed entire regions. Smoke rose in towering columns, darkening the horizon. The land trembled continuously as earthquakes rippled outward from the impact zones. Faults shifted, mountains groaned, and landslides thundered down slopes. Volcanoes awakened by the shock spewed lava and ash into an already darkening world. It was as if the planet itself had joined the violence. Convulsing with the weight of the double strike, in the skies the shock waves twisted the atmosphere into hurricanes of unimaginable scale. Winds tore leaves from trees hundreds of kilometers away. They were scattered like confetti in a storm of ash and dust. Pterosaurs, caught in the chaos, were torn from the sky. Their fragile wings were ripped apart by the violent currents. The very air that once carried them now became a weapon of destruction. Life in the seas was no safer. After the first impact, shock waves raced through the water, stunning and killing countless creatures. Coral reefs shattered, their delicate structures crushed by the pressure. Ammonites drifting peacefully only moments before were obliterated by the sheer violence. The once thriving oceans churned with death. They were filled with debris and boiling pockets of water that cooked life where it swam. And yet, as immense as the immediate destruction was, it was only the beginning. The most profound change was in the skies above. Billions of tons of vaporized rock dust and ash were blasted high into the stratosphere. This debris spread rapidly, encircling the globe in a shroud that blotted out the sun. Within hours, daylight dimmed. Within days, the brightness of the world was gone. The surface of the earth glowed with flames as wildfires raged. Continents burned in vast sheets of fire, producing smoke that rose to join the dust and ash. The fires consumed oxygen, leaving behind suffocating air. The air was filled with carbon monoxide and toxins. Creatures that survived the initial impact stumbled through a world that was rapidly becoming unrecognizable. Herds of herbivores collapsed from heat and smoke. Their vast bodies piled upon one another in silent testimony to the scale of destruction. Predators, once masters of the food chain, found themselves without prey. Their keen senses were overwhelmed by ash-filled winds. Smaller creatures burrowed underground or hid in water. Their survival hinged on instincts honed over millions of years. Yet even they faced dwindling chances. In the oceans, tsunamis continued to roll for days, slamming into distant coastlines. Entire ecosystems were uprooted and swept away. Coastal plains were drowned beneath layers of sediment, As the skies grew darker, photosynthesis began to fail. Plankton, the foundation of marine life, died off. This set in motion a collapse that rippled upward through the food chain. The dinosaurs, rulers of the earth for so long, faced their first true defeat. This was no predator to outwit, no drought to endure. It was a force from the heavens, a double strike that left no sanctuary untouched. The chaos of that moment is almost impossible to comprehend. Two asteroids, each devastating enough on their own, had combined their power. They unleashed a storm of fire, water, wind, and ash. The age of dinosaurs, built upon resilience through countless changes, now teetered on the edge of collapse. The planet itself was scarred forever. The craters marked the places where fire had met stone. Reminders of the fragility of even the mightiest creatures when faced with cosmic chance. And though the Earth would one day recover, for those living in the shadow of that moment, there was no escape. The age of dominance was ending. The silence of extinction had begun to take hold. In the days following the double impact, the Earth became unrecognizable. Where once there had been blue skies, the world now lay under a ceiling of ash and dust. It was so thick that sunlight could barely penetrate. What little light reached the surface was weak, dim, and grey. Shadows disappeared because the entire world was in shadow. The first nights after the impacts were darker than any night the Earth had known before. Even the stars were obscured, hidden behind the veil of particles high in the atmosphere. Creatures that had once navigated by moonlight or starlight found themselves disoriented. Birds and pterosaurs, those few that had survived the storms of fire, struggled to orient. The sky no longer offered guidance. Temperatures plummeted. Without sunlight, warmth bled away into the void of space. Mornings were cold and damp. Afternoons brought no relief. Nights became deathly still and frigid. The lush, warm Cretaceous world of just days earlier had become a place of bitter cold, a place of suffocating darkness. This period is known as an impact winter. Plants, the foundation of the food web, began to wither. Leaves turned black stalks, shriveled, and the once vibrant forests fell silent. For the dinosaurs, this was more than a catastrophe. It was the unraveling of their existence. Herbivores like Triceratops, Edmontosaurus, and Ankylosaurus found their food vanishing. Without sunlight, photosynthesis ceased. The green world that had sustained them collapsed in weeks. Weakened, hungry, and desperate, they wandered across barren plains. Their calls echoed hollowly through landscapes stripped of life. Predators like Tyrannosaurus, Gorgosaurus, and Daspletosaurus followed, but their own survival depended on the survival of herbivores. When prey grew scarce, they turned on each other, scavenging carcasses or fighting bitterly over the remains of those that had fallen. The oceans fared no better. Plankton, microscopic but essential, began to die as sunlight failed to reach the upper layers. With them perished the base of the marine food chain. Ammonites, once abundant and diverse, drifted lifelessly through the water. Mosasaurs and plesiosaurs, which had dominated the seas, faced starvation. Fish populations dwindled. Massive waves from the initial impacts had already devastated marine ecosystems. But the slow death of the oceans in darkness ensured that few species could recover. Ash and soot rained down continuously. Some of it fell as black snow, coating the ground in layers. It smothered plants and poisoned rivers. Rainfall mixed with sulfur from vaporized rock, producing acid rain. The rain burned leaves, corroded soil, and turned freshwater habitats toxic. Amphibians sensitive to the slightest change in water chemistry perished in droves. Streams and ponds that had once supported thriving ecosystems became barren. Their surfaces were coated in oily films of ash. Wildfires ignited by the returning fragments of molten rock continued to burn. They raged long after the impacts. Entire continents glowed red in the night. Lines of fire swept across plains and forests. The smoke from these fires added to the global shroud. It thickened the atmosphere into a blanket that trapped toxins and blocked heat. In the choking haze, creatures struggled to breathe. Lungs burned, throats tightened, and many suffocated long before starvation claimed them. Earthquakes and volcanic eruptions continued for weeks. The energy released by the impacts had destabilized the crust. It shook fault lines across the planet. Volcanoes poured out rivers of lava and columns of ash as if joining in the destruction. The combination of asteroid debris and volcanic ash created a hostile atmosphere. It no longer resembled the life-giving air of before. In burrows and caves, some of the smallest creatures endured. Mammals, still tiny and fragile compared to the dinosaurs, huddled underground. They fed on seeds, roots, and insects. Crocodiles lay low in rivers and swamps. Their bodies were adapted to withstand long periods of scarcity. Turtles buried themselves in mud and endured the long darkness. These survivors would one day inherit the Earth, but in this moment their existence was precarious. The dinosaurs, however, were not so fortunate. Their size, which had once been their greatest strength, now became their downfall. Large bodies required large amounts of food. In a world without sunlight, food was the first thing to vanish. Even the mightiest Tyrannosaurus rex could not stand against starvation. For months, the sun remained hidden. Temperatures continued to drop. The Earth entered what can only be described as a global winter. In some regions, snow began to fall, covering the blackened landscapes in white. A stark contrast to the infernos that had raged only weeks earlier. In others, the ground lay bare, cracked and lifeless under the constant haze. The silence of this world was haunting. Once the Cretaceous forests had rung with the calls of hadrosaurs and the shrieks of predators, now there was little sound beyond the crackling of distant fires and the groan of shifting earth. The chain of life had been broken. Plants were gone, herbivores starved, predators followed, and ecosystems collapsed. The dinosaurs who had survived countless challenges could not overcome this darkness. Yet amidst the devastation, life clung on. Seeds buried beneath the soil remained dormant, waiting for sunlight's return. Burrowing animals adapted to the dark found ways to endure. Insects, ever resilient, survived on detritus. Even in the bleakest moments, the spark of survival lingered. But for the dinosaurs that had once ruled the Earth, the aftermath marked the end. Their reign, which had lasted for more than 150 million years, was undone. Not by arrival, not by gradual change, but by a sudden darkness from the sky. The world they left behind was scarred and silent, a place of ash and shadow. But this silence was not permanent. One day light would return, plants would grow again, and new creatures would rise. They would take the place of those that had fallen. The Earth, battered but alive, was already preparing for the next chapter. As the ash settled and the long night of the Earth dragged on, the age of the dinosaurs reached its silent conclusion. Their story, written across 150 million years, ended not with a roar, but with a quiet, suffocating collapse. The twin asteroid strikes had brought devastation that was both immediate and enduring. Their aftermath reshaped the course of life forever. The great herds of Triceratops, once thundering across the plains, dwindled and vanished. Without vast forests and fields of vegetation to sustain them, they starved. Their horns, once used to fend off predators, now lay in the dust beside lifeless bodies, silent trophies of a vanished era. Hadrosaurs, with their crests that once filled the air with haunting calls, fell mute. Ankylosaurs, armored like tanks, proved no match for hunger. Even the mighty sauropods that still lingered in parts of the world finally fell. Their immense frames were too heavy to support on empty stomachs. Predators followed soon after. Tyrannosaurus rex, the undisputed king of the land, found its rule cut short. For generations it had stalked the Cretaceous with unmatched ferocity. Its jaws capable of crushing bone, its senses tuned to detect the faintest movements. But no predator could survive the collapse of the prey that fed it. In the days after the impacts, some scavenged the carcasses that littered the plains. But as weeks turned to months, even these dwindled. Weakened, starving and desperate, the last tyrannosaurs fought over scraps until they too fell. In the skies, pterosaurs fared no better. Once masters of the air with wingspans rivaling small airplanes, they were ill-suited to a world without abundant fish, a world without open sunlit thermals to help them soar. Their vast colonies crumbled, nests left empty eggs abandoned in the ash. The skies that once echoed with their cries grew empty. Only birds, smaller and more adaptable descendants of theropods, managed to endure. They scavenged hidden forests and consumed seeds and insects. Their resilience carried the lineage of flight into the future. In the oceans, extinction swept through with equal ferocity. Mosasaurs, apex predators of the seas, vanished. Plesiosaurs disappeared as well, their long necks no longer gliding through the waters. Ammonites, which had survived multiple extinctions before, were finally lost. Entire ecosystems collapsed, leaving behind empty seas choked with sediment. Their once thriving coral reefs were reduced to rubble. 66 million years ago, a mountain-sized asteroid roughly 10 kilometers across tore through space. It was on a collision course with Earth. Traveling at more than 20 times the speed of sound, it carried immense energy. It slammed into the shallow waters near what is now the Yucatan Peninsula in Mexico. This created the Chicxulub crater. The force of the impact was so immense, it vaporized rock and sent molten debris high into the atmosphere. This single catastrophic event is now widely accepted as the cause of the dinosaurs' extinction. The evidence was first pieced together by a team led by physicist Luis Alvarez and his geologist son Walter Alvarez in the 1980s. They discovered a thin layer of clay rich in iridium in geological strata around the world. Iridium is rare on Earth's surface but common in asteroids. They hypothesized that this layer was the fallout from a massive asteroid impact. Their theory was initially controversial. Many paleontologists favored explanations involving massive volcanic eruptions or gradual climate change. But the discovery of the Chicxulub crater in the 1990s provided the smoking gun. The crater, now buried under layers of sediment, was the right age and size to have caused a global catastrophe. The initial blast incinerated everything within hundreds of kilometers. The shockwaves and heat ignited global firestorms. The skies turned dark as dust and sulfur aerosols blocked the sun. The planet was plunged into an impact winter that lasted for years. Photosynthesis ceased and food chains collapsed. This was the reality faced by the last dinosaurs. A world of fire, then darkness and cold. Their size, once a mark of strength, now became a liability. Massive bodies demanded more resources than the collapsing ecosystems could provide. While some individuals may have survived the initial catastrophe, the chain of events that followed left little chance for recovery. The final hour of the dinosaurs was not a single moment. It was a cascade of disasters set in motion by a single rock from space. As silence settled over the Earth, the Cretaceous world gasped its last breaths. The giant reptiles that had defined an era were facing the end of their reign. It was a moment that would reshape the course of evolution forever. The firestorms and tsunamis were only the beginning. As the last embers of the global inferno smoldered, a deeper catastrophe unfolded. In the thin air of the stratosphere, billions of tons of pulverized rock, soot, and sulfuric aerosols spread. The Earth's blue skies dimmed into a permanent twilight. What sunlight managed to pierce the haze was weak and filtered. It cast the planet in an eerie, cold glow. Day and night blurred. The warmth of the sun vanished from the surface of the Earth. Temperatures plummeted rapidly. Regions that once basked in humid Cretaceous heat now shivered under a harsh chill. Plants that relied on sunlight withered within weeks. Forests already burned from the fires failed to regrow. Prairies and lush river valleys turned barren. In the oceans, the collapse was just as severe. Phytoplankton, the microscopic plants at the base of the marine food web, died off. Without them, the creatures that fed on them struggled. As these populations fell, the predators above them began to starve. The food chains across Earth crumbled with frightening speed. On land, giant herbivores such as Triceratops and Hadrosaurs faced an impossible challenge. They needed tons of vegetation, but there was none left. Herds dwindled to starving remnants. The predators that hunted them, including Tyrannosaurus, turned desperate. Some scavenged, picking at carcasses. But even these dwindled as decomposition slowed in the cold. Acid rain poured from the skies as sulfur mixed with water vapor. It seared leaves, poisoned rivers, and made survival even harder. Lakes and shallow seas turned toxic, suffocating fish and amphibians. Ecosystems unraveled, not in centuries but in mere years. The Earth had entered a new geological epoch overnight, one ruled by silence and scarcity. The oceans, once rich with life, fell into darkness. Coral reefs collapsed. Ammonites vanished forever. Marine reptiles, already battered, found their prey disappearing. Mosasaurs starved in empty waters. Plesiosaurs and other giants of the oceans followed the same fate. Only a few small, adaptable species persisted. On land, the silence grew unbearable. Vast forests, once filled with the cries of dinosaurs, now echoed with nothing. The long darkness lasted for months, stretching into years. Those who had survived the initial blast were trapped in a dying world. Dinosaurs were creatures adapted to abundance. Their enormous size, their specialized diets, their dependence on stable climates, all turned against them. It was a relentless chain of disasters. Mammals, small and resourceful, found their moment. Burrowing creatures huddled underground, insulated from the worst of the cold. Omnivores picked at seeds, insects, and whatever scraps remained. They needed far less than the giants who had once ruled. Birds, descendants of small theropod dinosaurs, found ways to adapt. They survived on seeds and insects, holding on to a lineage that would reclaim the skies. But for the great dinosaurs, the end was near. Each passing year without sunlight, each season without food, marked another step toward extinction. The long darkness was not just a physical shadow, it was a symbolic one, closing the final chapter on their reign. The earth had shifted violently. Nature was rewriting its story. This was no longer the age of dinosaurs. It was the dawn of something else, born from suffering shaped by survival, and destined to inherit the empty world left behind. The dinosaurs had survived countless challenges before. Their dynasty stretched for over 150 million years, longer than mammals or even flowering plants had existed. But the asteroid changed everything. The vast herds of herbivores began to disappear. Starvation swept across the land, and the great herds collapsed. Where once hundreds of hadrosaurs roamed, only a handful staggered through the dust-choked silence. Predators fared no better. Tyrannosaurus rex, once the undisputed ruler, faced a world where prey had become scarce. Hunger became the great equalizer, sparing no species. In the skies, the fate of the pterosaurs mirrored that of their terrestrial cousins, from the tiny Gorgonopsids to the colossal Quetzalcoatlus. They depended on the abundance of fish, insects, and small animals. As oceans emptied and forests fell silent, their skies became empty. Beneath the waves, the oceans faced their own apocalypse. Mosasaurs, plesiosaurs, and ammonites all disappeared. Entire lineages that had dominated the oceans for tens of millions of years ended abruptly. Some dinosaurs may have lingered longer in isolated pockets, but survival was no longer enough. The chain of life had broken. Their eggs, once laid in the warmth of fertile soil, now failed in barren ground. Their young starved before they could grow. Generation by generation, their chances dwindled to nothing. The fall of the dinosaurs was a slow fading in some places. In others, it was sudden and violent. Whether quick or gradual, the end came all the same. An empire built over millions of years dissolved in only a few thousand, an instant in the scale of deep time. For the reptiles that ruled the oceans, for the pterosaurs that ruled the skies, and for the dinosaurs that ruled the land, the age of giants was finished. The earth itself had turned against them. Extinction was final. What remained were their smaller relatives, and a few survivors clinging to niches of survival. From that moment forward, the dinosaurs would live only in stone and memory. In the silence left behind by the fall of the giants, the world seemed empty. Forests stood still, charred and barren. Oceans rolled quietly, their surface disturbed only by the winds of a cooling planet. But extinction, while merciless, does not erase everything. In the cracks of devastation, life endured. Not the mighty, not the massive, but the small, the adaptable, the overlooked. The survivors would inherit the earth not by strength, but by resilience. Among them were the mammals. Tiny and unassuming, they had lived in the shadows of dinosaurs for over 100 million years. They survived by burrowing, by hunting at night, and by eating almost anything. When the asteroid plunged the world into darkness, these strategies became their salvation. Safe in burrows, sheltered from fire and cold, mammals could wait out the worst. Their varied diets allowed them to find sustenance when the food web above had collapsed. While the giants starved, these small creatures managed to cling to life. Birds, descendants of small theropod dinosaurs, were another lineage that survived. Some small ground-dwelling birds endured. Many could feed on seeds which could survive long after plants had died. Their mobility gave them an advantage, allowing them to escape pockets of disaster. Though fragile compared to the soaring pterosaurs, their adaptability ensured that flight would not vanish. Crocodiles, ancient predators that had lived alongside dinosaurs, also survived. Their aquatic lifestyle buffered them from the worst of the fires and temperature drops. Their slow metabolisms allowed them to go for long periods without food. Insects, resilient and prolific, survived in staggering numbers. Scavengers and decomposers thrived on the remains of the dead. Their persistence not only kept them alive, but also provided food for other survivors. The hum of insects became one of the first sounds to return to the silent landscapes. Amphibians too endured. Frogs, salamanders, and their kin found refuge in lakes and streams. Their ability to hibernate allowed them to wait out harsh conditions. They persisted, proving that survival was not always about strength, but about patience. The pattern of survival revealed a truth. It was not the rulers of the Cretaceous who inherited the Earth. It was those prepared for hardship. Generalists thrived while specialists vanished. The massive and the mighty fell, while the small and the resourceful endured. Mammals, birds, crocodiles, insects, and amphibians became the seeds of the future. Each carried forward a piece of life into a new age. In the wake of devastation, they emerged into a planet forever changed. The dinosaurs were gone, but life itself had not been extinguished. It had simply taken a new shape, retreating into resilience. The survivors did not know it, but they were the ancestors of all that would follow: the rise of new predators, the growth of new forests, and eventually the emergence of humanity itself. When the skies finally began to clear and the dust of the asteroid impact settled, the Earth revealed a new face. The world that had once belonged to dinosaurs was gone. The forests that returned were different. The oceans carried new life. The silence left by the fall of giants was slowly replaced by the sounds of smaller emerging survivors. This was not a return to what once was. It was the birth of something entirely new. Plants were the first to reclaim the earth. Ferns spread quickly across charred landscapes, a phenomenon known as the fern spike. They carpeted the ground where forests had once stood tall. In time, flowering plants returned, taking advantage of the open space. They grew in vast numbers, spreading their seeds and reshaping ecosystems. These new plants would feed the creatures that remained. They offered the foundation for life to rise once more. With the dinosaurs gone, mammals stepped into a world of opportunity. No longer confined to the shadows, they began to diversify in an explosive radiation. Species that had once been small and shrew-like evolved into larger forms. They explored new roles in the ecosystem. Some became grazers, others predators. Many adapted to climbing, burrowing, or even returning to the sea. Their adaptability allowed them to spread across every environment. They filled the gaps left behind by the extinction. Within a few million years, mammals would grow into creatures larger and more complex. Indracotherium, a giant hornless rhino, became the largest land mammal ever. Whales evolved from land-dwelling ancestors to become giants of the deep. Birds too flourished. Their ancestors had survived by being small and resourceful. Now they expanded into new forms. Some, like the terror birds, became large, flightless predators, taking the place of dinosaurs. Others grew larger and filled the skies with wings once again. The age of birds had begun. Their songs replaced the cries of the pterosaurs that once soared above. They became the heirs of flight, shaping the skies in new ways. The oceans also transformed. Though mosasaurs and plesiosaurs were gone, the seas did not remain empty. Fish diversified rapidly. Sharks, survivors of countless extinctions, rose again as apex predators. They shaped marine ecosystems that persist to this day. From the shallows to the deep, the oceans filled with new life, different from the past, yet vibrant with energy. The Earth's recovery was not immediate. It took thousands of years for ecosystems to stabilize, millions for new forms of life to dominate. But the resilience of survival ensured that life would not only return but thrive. Each species that endured carried the potential for the future. Together they created a planet both scarred by disaster and brimming with possibility. The legacy of the asteroid was paradoxical. It had ended an empire, but it had also cleared the path for another. Without it, the dinosaurs might have continued their reign indefinitely. Mammals might never have risen beyond small nocturnal creatures. And primates, let alone humans, might never have walked the Earth. The catastrophe was both an ending and a beginning, a moment that reshaped the destiny of the planet. This raises a profound question about our own existence. It is a product of cosmic chance of a rock falling from the sky 66 million years ago. Our world was built upon the ruins of another. The study of this event also serves as a modern-day warning. Humanity now tracks near-Earth asteroids, developing technology like the DART mission to deflect potential threats. We are the first species on Earth with the knowledge and capability to prevent such an extinction. The story of the dinosaurs is a reminder of what is at stake. In the grand scale of time, extinction is both inevitable and transformative. It destroys, but it also creates. From the ruins of the Cretaceous world rose a new age, one that would eventually give birth to the modern Earth we know today. The asteroid that killed the dinosaurs did not kill life. It redirected it. It set the stage for the rise of mammals, the eventual emergence of humanity, and the civilizations that now look back to that day. It was one of the most pivotal moments in history. The world after the asteroid was quieter, stranger, and emptier, but it was also full of potential. The survivors, small and overlooked, inherited the planet. They built new ecosystems, forged new paths of evolution, and carried life into the future. And so, from the ashes of destruction, a new world rose, proving once more that even in the darkest hours, life finds a way.